3 more sections left. Yay! So we talked about solving system of equations, and I said there were 3 methods, and we talked about graphing, and you did that. Then we talked about substitution, and you did that. And today we're going to talk about elimination. Some books call this addition or subtraction. I call it elimination. Most books call it, your book calls it elimination. It is the most popular way of doing it, and we'll talk more today and tomorrow about why it's most popular. So in order to do elimination, these are the steps. You need to add the equations together, and that will eliminate a variable, and we'll show you how that happens in a minute. And then you'll solve for the remaining variable, kind of like we did with substitution, and once you get one of them, then you can plug it back into an original equation and solve for the other one. And then, because we're doing it by elimination, you're going to have to be sure you check your check your solution in both original equations. Even if you do it by substitution and you want to check your work, you're going to have to plug it into both equations. Even if you do it by graphing and you want to check your work algebraically, you're going to have to do it by plugging it into both equations. So that's kind of important to remember. You don't just plug it into one, you plug it into both if you want to check it. Now, we talked about how the fastest way to check is to check at the back of the book. But when you get on a quiz or a test, you can't do that, so you need to make sure you understand how to do this. Okay, so, by the way, you've already had your last quiz. Woohoo! Alright, let's go ahead and start. I have 2 examples that are already up here, and I'm guessing you've already written these notes down because I'm kind of blocking your way right now. If not, you're going to have to rewind and get them then. I'll do it in a different color so it'll show up really well. When you have 2 equations, sometimes you can look at them and you can say, okay, I really need to do this one by substitution because you've already solved for something for me, kind of like this one. Or you might look at it and say, okay, since they're already at y equals whatever, I'll go ahead and graph it because it's faster to do it that way. But this one screams out, solve me by elimination. And it does that because if I were to add these 2 together, then x plus x is 2x. But more importantly, a positive y and a negative y are going to cancel each other out. So I don't have any y's anymore, and that's what you're looking for elimination, is you're looking for one of the variables to cancel out. So here my y's canceled out, but I still have to add my 10 and my negative 2, so I'm going to get an 8. Now I have 2x is equal to 8. This statement is just as true as those 2 statements were. So since this statement is true, that means I can divide both sides by 2, and you get that x is equal to 4. Tell me that went easier than the stuff you were doing before. Just saying. Now that we know that x is equal to 4, I can take this back up here and plug it in and say 4 plus y must equal 10, which means y has to equal 6 because 4 plus 6 equals 10. Now that I know that x is 4 and y is 6, that gives me the point 4, 6. Now if I wanted to check this, like I said before, you have to make sure you plug it into both, and you're plugging it into the original. So I'm going to plug this into the black stuff that was there. So 4 is my x. 4 plus 6 really does equal 10, so that one's good. And then 4 minus 6 really does equal negative 2, so we know that it's correct. Now, one more time, remember you don't always have to check this way. You can check the way that's quickest for you. So if looking in the back of the book is quicker, then by all means, it's fine with me if you do that. For this one, you can't automatically say that something cancels out. But whether you can automatically say that or not, there are some rules that you kind of have to pay attention to when you're doing elimination. Number 1 is you need to have all the x's on top of x's, all the y's on top of y's, all the equal signs on top of the equal signs, and all the plain numbers on top of plain numbers. And we don't have that here. So the first thing I'm going to do is rewrite this whole mess. I want to rewrite it. so that it looks the way I want it to look. Now this had P and Q is alphabetical, so I'm going to put my P on this side where my Q is. So that means I'm going to have to subtract P from both sides. So that's going to give me negative P plus Q equals 16. And then I'm just going to move this one over. So that gives me negative P minus Q equals 0. Now that I have my P's lined up with P's, my Q's lined up with Q's, and my numbers lined up with numbers, and my equal signs on top of themselves, now I can go ahead and add the two together. A negative P and a negative P is negative 2P. My Q's cancel out, and 16 plus 0 is 16. Divide both sides by negative 2, and P equals negative 8. Now I can take that and plug it back in. So that's a negative 8 minus Q is equal to 0. Makes that a positive 8. 8 minus Q equals 0, so Q must be 8, because 8 minus 8 is 0. Which makes my point negative 8, 8. And once again, you can plug them back in. So that would be 8 here equals 16 plus negative 8, which it does. So that's all good. Now, the reason that elimination is so powerful is not only is it quick, it's almost quicker than substitution is sometimes, but it's so versatile. So not only can you just add stuff together when it's convenient that it crosses out, you can actually force it to be able to cross out. So let's look at another example. Let's look at this one. Oh, I wrote it wrong. Sorry. So this is the problem. And if you look, these two aren't going to cancel out when I add, those two aren't going to cancel out when I add, and these two aren't going to cancel out when I add. Which creates an issue. It helps if I write things correctly though, doesn't it? So that's what you get, which creates an issue. Because there's still nothing's going to cancel out when I add. But I could choose to multiply one of these by a negative 1. And since I'm going to multiply the whole equation by a negative 1, that doesn't change the value of anything. So it'll be just as true as this one is right here. So I'm going to leave the top one alone. But this whole equation I'm going to multiply by negative 1. So negative 3g times negative 1 is a positive 3g. Negative h times negative 1 is negative h. Negative 8 times negative 1 is a positive 8. Now I can add them together and cancel stuff out. So that gives me 10g equals 50. Divide both sides by 10. You get that g is equal to 5. And then I can take this and I can plug it back into this one, or this one, or this one, because all of them were true. So it doesn't matter which one I choose to plug it back into. I'll get this one since I swung up so high. So negative 3 times 5 plus h equals negative 8. Negative 15 plus h equals negative 8. And add 15 to both sides. And you get that h is equal to a positive 7. Whoops, don't do it. Which makes my answer 5, 7. If you don't believe it, go back up here and check. 5 times that is 35, plus 7 is 42. Negative 15 plus 7 is negative 8. It's got to be able to work in both. Now I know that was kind of a rough rush through, but I think you can handle this. It's not hard at all. Most of the problems that you're going to have are going to look like this, where they automatically cancel out, or they're going to look like this, where you'll have to rewrite them, which I know you know how to do, or they're going to look like this, where you're going to have to multiply by a negative 1, and I think you can handle that part. So, on page 461, for your classwork, numbers 1, 5, 9, and 13. And then for your homework, numbers 3, 7, 11, and 15. And you'll see me tomorrow.